Hello, this is also a CST basic tutorial, and in this video I would like to explain more about these options in modeling window. So I will be going through different options like Boolean functions and shape toolings, cutting planes, what is the importance of local working coordinate system, etc. So let's see that. So here I have considered a structure, and if I want to create some slots in this structure, what I can do is I can use these options like Boolean. So now I'm going to create a solid like having some length and width. So here you can see that one structure is created here. So if I really want to put this slot on this structure, what I can do is I can select the patch and I can use this Boolean operation. So if I go for the subtract and select this solid one, you can see that a slot is getting created. So I'm just going to delete that operation from the history list to show other operations also. Okay. So I used the history and I deleted that operation. So now I'm going to use other Boolean operation. So I'm going to select the patch and I'm going to use intersect. So here itself you can see how this operation works. So if it is like adding, both the structures will be added, and subtracting, the second structure that will be getting subtracted, and if it is an intersect, the common portion of both will be uh, remain there, and if it is an insert, it's like both will be there. So let's see how the intersect work. So I just selected both. Here you can see that what is the intersection of both the patch and the structure is remaining here. That is how the intersect work. So this is some of the operation that can be used to create different types of structures. And this transform operation is if you want to do some modifications like translation, rotation, scaling, or mirror. So if it is like translate, if you click on translate, you can see that this arrow will be indicated in different directions. You can see it is, you can move in X, Y, and Z directions. So these directions you can give it here. Based on that, it will be get moved. So if I want to move 10 mm along the Y, you can give it here. So here you can see that it is getting moved. So that is the translation operation, and if it is rotate, it will be getting rotated. You can see how the rotation is working. So here you can do the rotation along the shape center or along the x0, y0, z0 axis, which is the center of the coordinate system. As I have moved the patch 10 mm, this center and the patch center is different. So you can choose whichever is your shape center for the rotation. So in which axis if you want to rotate, if it is along, this is the axis, you can put the value here, like different values here, and see how this rotations will be working. And one of the main important thing is scaling. Scaling is very important factor. So like if you have designed an antenna at some frequencies, and if you have to scale this antenna at a different frequencies, you can use this structure. So it is not like you don't have to change all these parameters. So if you want to divide all these parameters by 2, you can use this function. So if it is like if you are going to scale, you can like here you can see now everything is reduced to half. Like this you can scale the structure. So scaling is one of the important thing that we will be using if you are going to design an antenna for different frequencies, and if you want to find out how it will be impacting. So if you want to scale the structures, you can definitely use this scale parameter. And okay, and if you have if you have to means bend the structure, so sometimes we may have to design the antennas, which is usually for the wearable application. In that time, we may have to design the antennas on the textiles, and we may have to bend the structure. So in that case, you can use this operation bend tool. So one of the important thing you have to consider is we will be having a global coordinate system, that is this XYZ, which is usually the center of this plane. And here you can see that local WCS. WCS means working coordinate system. So we can have different local coordinate system. So we can do different operations using the local coordinate system. So if I am going to select this face, so if I want to if I want to create a local coordinate system on this face, what I can do is I can go for like pick points. Here you can see that sorry, pick here you can see that if you have to pick face, the shortcut is F. So if I just click F, this will be selected, and double click it, and if you click on the local WCS, it will be aligned with respect to that face. So now you can see that UVW, here you can see that in local coordinate system, U is aligned with respect to X, V is aligned with respect to Y, and W is aligned with respect to Z. So this coordinate you can be used to uh, do the modification. So if you have to bend this structure, you can always use the local coordinate system. So here you can see that bent shape, so and cylindrical bend. So usually you can go for the cylindrical bend. So here you can see that the bending is happening along the W axis. That means that W is along this direction, so that is it is getting curved to the top. But in variable application, it is like you may have to um, drag the structure on any textile, so the bending has to be on the opposite side. So in that case, what you have to do is you have to rotate this local coordinate system, so this W will come on the opposite side. So here you can see the options like transform WCS. So you can click on that. Oh, sorry, you can click on that. So you will be getting some options like move. So here, if you want to move like along U, V, or W, you can specify some dimensions. So if I want to move maybe 5 mm on the top, you can do this move option. So now my purpose is to so my purpose is now to rotate W on the opposite side. So I'm going to use the rotation. So here you can see that rotation can be happen in any of these coordinate systems. So my purpose is I have to rotate W to other side. So if I means handle here, and if I rotate, this W can be rotated to the bottom, so like this. So if I use this rotation like 180 degree, you can see that the W coordinates that is which is corresponding to Z is on the bottom part. So you can use that option. So now I have rotated this thing, and if I use the cylindrical bend, you can see that how the bending is happening. So here you can use the one-sided bend. So in that case, you can see that only one-sided will be bent. So this is, you can see here, only one side will be bent. So you can use the two-sided bending, and you can use the radius, like based on the radius, the bending will be different. So now you can see if you need only mild bending, you can give a large radius here. And if it is like sharp bending, you can use smaller radius here. So here, that is how the bending is done. So here you can see that how the patch antenna is bent, and this is how we are bending the structures for the wearable applications. And okay, so this local coordinate system is very important. And if you uh, see okay, so if you want to have any modification on these uh, local coordinate system, you can use any of these options. So it's easy to, if you want to move the local coordinate to this point, you can just click select the point, and you can use align WCS with the selected point, so it will be moved to that point. So this is how it is done. Okay. And maybe if sometimes if we have designed these structures like this, and we will be using the parametric structures, parameterization, so we will be seeing like if a parameter, like maybe we can check what is the patch dimension. So the patch dimension in this case is W and L. So in some cases, we may have to see how the width parameter change is having the impact on the structures. So if you want to see that, you can use this option, animate parameter, and you can give the value here, whichever you have to animate, you can give it here. So if I want to see how the W is varying, I can I can go from start value to some value, and I can just animate it. So you will be able to see how the structure is varying with a step of 5. So using this, you can easily visualize if any of these parameters is suitable for the modeling or not. If this parameter is going outside of this design dimension, we don't have to go for that parameterization. So this is just for the visualization purpose. And these pick points are mainly for picking different parameters. It is also has a lot of importance. And so here, if you go for, okay, maybe I can show you this one, modify locally. So if you have some structures like this, some complex structures, and if you have to means elongate this face, you can use this option, modify locally. So let's see that. So I'm going to select this face, and I'm going to use modify locally. So I'm going to modify this face. So here you can see that you can move the face, remove the features, lots of things you can be done. So here I am going to move the face. So maybe I can move the face along Z. So 10. So here you can see that that face will be moved by this much distance. So this is this one. And okay, and we also have this thing known as the shape tool. It is also important, like if you have to design an antenna for any of these installation applications. So sometimes in automotive radar, if we have to install the antennas at different positions in the car. So it is like if you have a automotive like this, and if you have to design an antenna to install at this position, so I have to design an antenna to install at this position, you have to consider this area as the ground plane. So you will be getting the CAD model for this entire structure, but you have to cut this much part for the simulation areas. You don't have to consider the entire CAD, you have to consider only a small part. So in that case, if you have a very large CAD structures, you can use these tools to like modify the shapes and everything. So in this case, when you are using the import functions, you can import the CAD models. And once this CAD model is done, what you have to do is, first thing you have to do is you have to heal all the shapes. So all the shapes CAD model will be executed, and it will be like smoothened for the mesh execution. So it is very important to have this thing heal all the shapes, and it has different options to clean the faces. So these are very important for the meshing purpose. If your CAD model is very complex, you have to use these shape tools. So here I would like to show one of the important parameters, slice UV plane. So in our previous case, we have seen that we have to cut a small part of the CAD model. So let's see if I want to cut a small part from this model, like I have to cut half of it. What I can do is I can go for local coordinate system. So what I'm going to do is I'm going to select midpoint of this line. So if I click M, it will be selecting the midpoint of any of the spaces. So I just click it here, and I'm going to align WCS with selected point. So here you can see that your coordinate system is aligned, and you can use this option, slice by UV plane. So this means that I can use this option to cut this structure. So it will be cutting based on this UV plane. Here you can see that this UV plane is along this thing. So if I want to cut like this, I have to rotate this plane. So what I can do is I can use the transform WCS option, rotate, and so I have to make sure that U and V plane you can cut this structure. So now you can see that this is the U plane and this is the V plane. So if I consider this plane, it can cut this structure. So like this, I can align the UV plane, and what I can do is I can use slice by UV plane. So here you can see that the solid force structure is divided into two, and I can delete this structure if I don't require that. So this is one of the options that we can use if you have to cut very large CAD models into small structure, and can be used for your simulation. So that is the importance of shape tool. So this shape tool is very important if you are dealing with very heavy CAD structures. I think that's all about the modeling of these structures. I hope you get some ideas. Thank you.